Hey calculus kids, this is Dr. Callahan for week 5 Friday. This is now the 6th consecutive day of distance learning. I hope to see you guys soon, possibly on Monday. It's forecasted that they will have a strong gust of wind this weekend, and that should probably take care of this. So in the meantime, go ahead and pause the video and do the following 3 questions in your warm-up log. All right, let's go ahead and take a look at this. So here it's asking you to find the asymptotes. The horizontal asymptote is actually pretty easy to find because all you have to do is just look at the biggest power. In this case, it's 4 and 4, so they're exactly the same. So then you just look at the leading coefficient. So that's 2 over 1, which means your horizontal asymptote is at y equals 2. So 1, 2, so we have a horizontal asymptote right here. Now the vertical one is a little bit more challenging because remember before you can just factor the denominator set equal to 0, you want to make sure if there's another factor in the numerator that you can cancel out with. And in this case, if you look at the denominator, which is right over here, what you can do is it is an x to the 4th power. So I know I can factor it as if it's x squared. And you don't want to find anything, you're going to ask yourself, what times y equals 900? So you know that the first thing that you're going to have is going to be an x squared and an x squared. And the second thing you should ask yourself is, okay, what times y equals 900? But then when I go ahead and I add them together, it will give me a negative 61. Given the fact they have an x squared, wow, that was kind of loud, sorry about that. Given the fact that there's an x squared right here, your first thought should be about perfect squares. So if you think about perfect squares, you can either have 4, 9, 16, 25, 36, 49. You know the factor here is going to have to be a perfect square because with the x squared, it's with the intent that you're going to factor it again. And so which one of these factors multiplied together will go ahead and give you a 900. And these two, interesting enough, will give you that 25 and 36. So I'm going to go ahead and put a minus 25 and a minus 36 because the product has to be a positive 900. So then from there, you can actually factor it a little bit further with the first one, x plus 5, x minus 5 for the second one, and then you can go ahead and factor x squared plus or minus 36 a little bit further as a positive 6 and a negative 6. So that is going to be your denominator. Now your numerator, you're going to have to do a little bit of work as well because it looks a little bit obscure and the coefficient is actually greater than 1. So then what does all these numbers have in common? You have a 2 in common, and also you have an x squared. So I'm going to factor out 2x squared, which is going to give me an x squared plus an x minus a 20. And then I can go ahead and factor this even further. Oops, there we go. Which is going to be an x. Sorry, I can't actually see this because now the bar is blocking the way. Oh, great. Okay, move it over here maybe. Sorry about that. Okay, here we go. And you have, this is really awesome. All right, x minus 4, x plus 5. So then what you're going to do is then compare the numerator to the denominator. Is there anything that I can cancel? And yes, I can actually cancel an x plus 5. So that is gone. And then is there anything else that I can cancel? Yes, there is, because I just realized I made a little typo here. And if you look over here, it's not 20, it's supposed to be 60. So it should be 30. Sorry about that. And actually that will eliminate this. So let's just take a step back. I made a little whoopsie here. All right, so that should be a 30, which would change this and modify it because you will have to have minus 5 and a positive 6 to get to a negative 30, but a positive 1 when you add it together. So my bad. So then let's go ahead and cancel that. So x minus 5. There we go. X plus 6. Here we go. And so now we only have x plus 5, x minus 6 left in the denominator. So my vertical asymptote is going to be a negative 5 and a positive 6. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So I haven't graphed this yet, but it probably will look something, I don't know, I'm just making a guess, but maybe something that looks like this perhaps, something like that. Don't know for sure because I haven't graphed it, but I'm assuming that's what it'll look like. Anyways, but you have your vertical asymptote and you also have your horizontal asymptote. Most questions will probably not be as this complex, but I want to make sure that if you do have a complex question, you have the strategies to go ahead to work on this. Okay, so then with that said, let's go ahead and move forward. So take out your guided notes, your white packet for week 5 Friday, which you guys should have. So last time I saw you guys, we went over the review of Unit 1, which is on limits. Today we're going to continue that review, but we're going to work a little bit more on specifically trigonometric limits. And so I'm going to go over a few more complicated examples, because it seems like that's always something that kids do not remember from trigonometry, is identities of trigonometric functions. So with that said, let's take a look at your guided notes for today. This is a breakdown of what we have. We're going to first work on trigonometric limits. We're going to do a chapter 1 summary fill out. It's not summer, summary. Forgot a A and an R and a Y. Then we're going to do a whiteboard practice, although we're doing distance learning. So really it's not going to be a whiteboard because there's no whiteboards. And then we're going to work on questions for worksheet number 5 and 9. I will give you guys the answer. There is a calculus puzzle on E, limits on horizontal asymptotes. And then do not forget your Math Excel homework for this week, for week 5. I usually have 2 assigned. The first one is Monday, Tuesday, and the second one is Wednesday, Thursday. As always, it is due on Sunday. So keep that in mind. So with that said, let's go ahead and take a look at your guided notes. So turn your notes over to this page. You should have first page, your second page, third page, fourth page. So 4 pages, or just 2 pages front and back. All right, so now what I want you guys to do is turn over to this page right here, and we're going to go over these questions on the trig limits, and you can pause the video, maybe try to get started on some of them yourself, see where you guys get to. Some of them are a little bit tricky. We'll start off something easy and then get to the more difficult, complicated ones. If you look over here, these are the 2 that we went over, and these are the 2 that you want to memorize as well. So just remember the limit as of theta or x, whatever you want to do it, as x approaches 0, cosine x is 1. The limit as x approaches 0, sine x equals 1. And then the next one is the limit as x approaches 0, sine x over x equals 1. So those are the 3 that we're going to be working on, or working with closely. Normally in class, I will have you guys do this on your desk, but today it's kind of a weird setup for virtual, so we'll just go ahead and work on it together. All right, so let's go ahead and take a look at the first one. If you want to pause the video, you can go ahead and maybe try to go ahead and work on this one. The reminders are on the side. Okay, so as I'm looking at this, it's like, which one of these 3 special trig limit formulas am I going to use? Most likely, I'm going to use the limit as x approaches 0, sine x over x equals 1. Except here, I don't have a sine x, I have a sine 2x. Okay, no, go back. So I'm going to put a 2 right here. So then how do I go ahead and make this equation to match this special formula? Well, I know I can rewrite this bottom part as this. So then what I can do is I can take this 2, put it in the front of this limit, have x approaches 0 for sine 2x over 2x. Now what's going to end up happening is that this entire thing here will just become a 1. So then what is my answer? It is just 2. So pretty simple, right? So starting off, kind of easy. Okay, next one. Take a look at this one here. Pause the video, give it a try yourself. All right, so my next question is, what is my goal? Which one of these 3 am I going to use? My goal is to get sine 11x over 11x, because as a limit x approaches 0, this entire thing becomes a 1. So is that a possibility? Well, I have 11x on top, but I have a 3x on the bottom. Would be great if I can move this 3 out to a 1/3, and then maybe I need an 11 on the bottom, so it would be great if I can multiply by 11 on the bottom, but then whatever I do on the bottom, I'm going to do it on top. So you can multiply anything by 1. That's totally legit. It's totally fine. And then I'm going to move this 11 out in the front as well. So I have 11 over 3, limit as x approaches 0, sine 11x over 11. And ta-da, that is achieved. Goal, check it off, done, boom. So this entire thing then becomes a 1. And so what is your answer then? It is going to be 11 over 3. Hope you guys are keeping up. All right, next one. Once again, think about this and ask yourself, what is my goal? What do I want to get to? This one's obviously going to be a little bit of an upside down one. You can still use this limit, but you want to reverse it. So it's going to be as theta approaches 0. You can flip it. Theta over sine theta is going to equal to 1. So let's go ahead and rewrite this then. Okay, I'm going to have a theta times a theta over sine theta, limit as theta approaches 0. Well, I'm just going to take one of these theta and just put it on the outside there. So then I have theta, limit as theta approaches 0, theta over sine theta. And goal achieved, check. This is going to turn into 1. So then what is my answer? As a limit of theta approaches 0, it's just theta times 1, which is theta. So here are some other interesting strategies of evaluating limits. So take a look at this of how you can actually get rid of certain things. These are the most common ones that you can actually utilize. Because we will be using some of these, like for example, this part right there. And I know it looks absolutely crazy, but initially, this is really just multiplying everything by 1. So it's completely legal. All right, let's take a look at this. It looks really compact, really beautiful, but guess what? It's actually kind of a more sophisticated problem. So what is your goal? I know it's not quite evident based on what it's written as tangent 5x over x, but going back to trigonometry, you guys use your trig identities kind of backwards and forwards. Another way of writing tangent, as you guys know, is sine over cosine. And so then my goal is that I want to have a limit as x approaches 0 for sine 5x over 5x, which are then equal to 1. Well, I could see that happening, but there's a cosine 5x in the denominator of the numerator that's kind of getting in the way. So then how do I go about making that happen? Well, remember, one of the strategies is that you don't want to have a fraction on top of a fraction. So let's see if I can maybe get rid of this part right here by rewriting this. So I have sine 5x over cosine 5x divided by x, but then it's the same thing as times as 1 over x. So then what I want to do is I am going to try to get rid of the cosine. So maybe I can move the cosine to the very front of this limit. But then I'm also missing a 5 on the bottom, right? So then maybe I should multiply the denominator by a 5, but then I can also multiply the numerator by a 5 because essentially it's just 1. But I'm going to take this and also put it over here. So then what ends up happening is you have a 5 over cosine 5x, limit x approaches 0, and here it goes, sine 5x over, look how beautiful this is. You have a 5x now. And ta-da, the goal is achieved. Check that baby off. And then this part becomes a 1. So what is your answer then? 1 times the coefficient here is just going to give you 5 over cosine 5x. But here's the other thing. You also have the limit as x approaches 0 because you're splitting this limit. So here's your first limit, but then when you split it, you also have a limit right here as x approaches 0. So then 5 over cosine 5 times 0 is 0. 5 over 1, which is just 5. I know, a little bit complicated, but guess what? You guys are super duper smart kids, and I have all the confidence in the world that you know how to do this. All right, take a look at the next one. Pause the video. All right, so looking at this part right here, I am going to assume that, there's no way for me to use any of these awesome reminders or hints on how to get to a 1, 1, or a 0 with 2 signs. So my strategy here is to first maybe split it into 2 fractions. And I know you're like, what? Why would you do such a thing? We're going to split it into 2 fractions so then we can set the numerator as a limit and the denominator as a limit using one of these reminders. So if you focus on the numerator, you're asking yourself, what else do I need to get to a sine theta over theta? Well, I will have to multiply the denominator by a 5x. So balancing it, I will multiply the top by a 5x. For the denominator one, what would I need to get to a sine at 2x over 2x? I will need a 2x top and bottom. So then if I can go ahead and rewrite this, I will then have this part, which I don't technically need, moved over to the front. So I have 5x sine 5x over 5x divided by, move this one over to the front, 2x sine 2x over 2x. And then let's go ahead and set the limit as x approaches 0. You know, this part right here is going to become a 1. This part is going to become a 1. And interesting enough, this x and this x will cancel. So what do I have left? Just 5 over 2. How beautiful is that? Okay, take a look at this one here. All right, so as I'm looking into this, I know that with a cosecant, you will have to rewrite this in order to use one of these shortcuts or reminders. And I know that another way of writing cosecant 9x is 1 over sine 9x, and this is from Trig. So let's go ahead and rewrite that. So I'm going to have the limit as x approaches 0. I have my x right here, don't forget that. X times 1 over sine 9x divided by, don't forget your denominator, cosine 12x. In order for me to go ahead and use one of these here, I can also do the reverse of this. My goal is to get the limit as x approaches 0, that I will have a 9x over sine 9x, which will give me a 1. So then what am I missing here? Well, I have an x in the numerator, but I'm missing a 9. So if I multiply a 9 on top, I will have to multiply a 9 on the bottom. And I know I want to keep this 9, so it's right here. But this 9, I don't really need, so I'm going to move it to the front. So I'm going to have 1 over 9, limit as x approaches 0, 9x over sine 9x. So this part right here is this with this. But then you also have your cosine. So what am I going to do with a cosine 12x? I'm just going to go ahead and put divide by cosine 12x, but then of course if I change from a division to a multiplication, it will be a 1 over cosine 12x. And so this is one of those special cases where you're going to be splitting the limit into 2. So then the limit as x approaches 0, this entire thing becomes a 1. 1 times 1 over 9 is 1 over 9 times what is the limit as x approaches 0 for cosine of 0? Well, remember 1 over cosine of 0 is 1 over 1. So this entire thing becomes a 1. So then what's 1 over 9 times 1? Just 1 over 9. All right, let's go on to the next one. All right, this will be your last one, and it's also a very ugly one. So take a moment, kind of strategize what you're going to use, what your goals are. Okay, initially when I'm looking at the numerator right here, I noticed that there's a 4x and a 4x. So I'm going to try to maybe take that 4x out. If I do that, I have a 1 plus cosine 4x remaining over sine 4x times cosine 4x. So then I'm going to ask myself, okay, is there any way for me to use one of these formulas? And I can see that I have a sine 4x with a 4x. So I'm going to split my limit. So my first limit is as x approaches 0, I have a 4x over sine 4x times, and I have a 1 plus cosine 4x over cosine 4x. I know that this first part right here will become a 1. And the second part, there's nothing that I can do to make the second part here using one of these reminders. And you don't have to use those reminders, but it's always good to be able to use it. And I always want to use it on the ones with a sign, because if I use direct substitution, the sign is the one where it always kind of messes me up, because sine of 0 is 0. And if that's something in the denominator, it's always undefined. However, I don't have that issue with cosine in the denominator, because cosine of 0 is just going to give me 1. So if I use direct substitution with the second limit, that's completely fine, because it's not going to result in an undefined with a 0 in the denominator. So let's just direct substitute 0 here. Well, cosine of 0 is just going to give me 1. So here I have a 1 plus 1, 1 plus 1, divided by cosine of 0. Well, that's also going to be a 1. So that's what's going to happen. 1 times 2 over 1 is just going to give me a 2. All right, you guys, I hope that helped. That was actually quite a bit of work to be following along. So for the remaining part of the class, I was hoping that you guys can go ahead and practice a few things. First thing that I want you guys to practice is right here. Go ahead and fill this part out. It's a chapter 1 summary of everything that we've done, that we talked about. Pause the video, because I'm going to show you guys the answers right now. Okay, second thing I want you guys to go ahead and take a look at is, what did the asymptote say to the removable discontinuity? Pause the video. And the answer is, don't hand that holier than thou line to me. Here on the left side, I have additional practices that you guys can do. And then I have the worksheet number 5 and number 9 in the packet as well. The questions are given to you, but also the answers are on the side as well. So if you take a look over here, here are the answers for number 5, which is right here. Here are the answers for number 9, which is right here. And just so you know that this part is a continuation right here. All right, you guys, I hope you had a wonderful Friday. I hope to see you guys on Monday. Take care.